electronics of synchronous machines. Last class we stopped at this point here, the frequency and the voltage control of synchronous generator. Now شباب, let me start from the beginning, discussing the difference between independent and dependent synchronous machine operation. We had a laboratory this week, last lab, which is related to synchronizing the synchronous machine to electrical grid. And we discussed the synchronization condition. If you remember, after connecting the generator to grid, we started playing with the power of DC motor, which is the prime mover of the synchronous machine, by means of changing the supply voltage of the DC motor. And also we played with the excitation voltage or the field of the synchronous machine. And what was the response of the machine due to changing power or due to changing excitation voltage, شباب? Is there any change in the supply frequency, or was there any change in the terminal voltage after synchronizing the machine with grid? طبعا it's impossible. Why? Because synchronous machine is connected now to grid, and the grid is very huge system. You cannot change the frequency or the voltage of the grid. Time. How we can make the synchronous machine, or how we can make the grid constant voltage and constant frequency? This is made by two different systems. One is called automatic voltage regulator, and the other is called speed governor. Let's make another slide here just to declare the points. We have it here. We don't need to make it. Let's see this diagram first, شباب, in order to recognize the operation of the two systems we have. Now, شباب, assume we have at case number 1 here in this phasor diagram. As you can see here, we have IA1. This is a loading condition, and VT1 is the terminal voltage of the generator, and EF1 is the excitation voltage, or we can say the generated voltage. This is not the source, this is the EMF voltage we have. Type. What will happen if it is an independent generator and the current has been increased from IA1 to IA2, as you can see in the phasor diagram, and we did not change the excitation voltage. We did not increase the field of the synchronous machine. What will happen is like that. If you can see here, assuming the increase in power will lead only to increasing current, yani assuming constant power factor. So for the same value of excitation, you will find that this is the locus of EF constant here. You will find that due to the high current IA2, so GIA2XS will be like that value, this high value, or this high value. And in this case, because we did not change the excitation yet, you will find that the terminal voltage will be decreased. This is exactly what happened to synchronous generator if it is not connected to infinite bus, or if there is no automatic voltage regulator controller. So what is the aim or purpose of the automatic voltage controller? The purpose of the automatic voltage controller is to increase the excitation value such that keeping the terminal voltage constant. So at case EF3, we increase the excitation value with the same value of current. تمام يا شباب؟ This is going to keep V terminal constant. So, in order to keep V terminal constant as VT1, we have to increase the excitation value from EF1 to EF3. Is it clear يا شباب? What is the purpose of the automatic voltage controller now or automatic voltage regulator?
Doctor.
أيوه اتفضل.
You said that if it's not even connected to a bus, like would be like if it was connected to a bus, would it be different?
If the generator is connected to the infinite bus, small synchronous generator, it will be automatically coupled with the grid. However, if it is independent and we need to make the voltage constant, we have to use this AVR. Okay? Fine. In power plants, what has happened? طبعا due to the high power generators in power plants, we have to use this system, AVR. Okay? And this is the reason why the grid voltage is constant, because there is all of time an AVR system connected to all of generators, which makes the terminal voltage constant. So this is the reason why the terminal voltage is constant for all of grids. تمام يا شباب? Because there is an automatic voltage regulator system or controller. تمام؟ Is the phasor diagram اتفضل.
Actually, my question what is the purpose to increase the current? This is because of the load increased?
Exactly, due to suddenly increase in the load or even gradually increase with the load. Okay, يعني for any increase in power, the excitation will be increased like that in order to keep the terminal voltage constant. So this is now the aim of using AVR system.
So doctor,
اتفضل.
after synchronization, the only way to increase the excitation voltage is using the AVR system?
Again, your question? For synchronization?
After synchronization.
After synchronization, yes.
The only way to increase the excitation voltage is by using an AVR system?
Yes, AVR is the system that controls the excitation. Okay.
That means we wanna to, can we say in other words, that means we wanna just to save our grid to be stable?
Yes, in order to have constant voltage. This is now in terms of voltage. So here, if we have power increase, we have to increase the excitation in order to keep our voltage constant. Is it clear from phasor يا شباب how we could conclude it from the phasor diagram here?
Yes.
Can you draw the phasor diagram systematically like what we have described now? يعني firstly, we have case number 1, IA1, V terminal 1, EF1. This is step number 1, where the operation was stable at certain power, where IA1 was absorbed from the generator. Then, when the power demand increased, the current increased from IA1 to IA2, so suddenly increase in power will lead to suddenly decrease in voltage. How? The excitation volt is still at the same value before of the AVR action, so we expect to have lower voltage. How we can get this voltage? Simply, we have now IA2, so we have higher GIAXS. So assume this is the corresponding increase in vector IAXS. So we have now, this is the new voltage value VT2. This is before the action of the automatic voltage regulator. When the automatic voltage regulator takes his action, what will happen? It will increase the excitation gradually until reaching to the terminal voltage value again. Okay, شباب? Is it clear? طيب, how we can get the corresponding excitation voltage needed in order to keep the terminal voltage constant? Just take the same value of IAXS and move it after V terminal 1. Okay, so this will be the resultant required voltage, which gives you the same terminal voltage. Is it clear, شباب?
Sorry, doctor, I have a general question. Can we control the synchronization machine speed, or it will speed on its maximum RPM?
We are going to discuss the speed now, according also the increase of power. But now let's focus on the voltage in this phasor diagram. Yani I will answer your question in the previous slide. Yani we are going to discuss it now. But for now, شباب, regarding the voltage, is it clear how the AVR system can change the excitation voltage in order to keep the terminal voltage constant? So now, شباب, if we said what is the AVR target? What is the target of AVR system?
To keep the terminal voltage constant.
To control the excitation voltage in order to keep constant terminal voltage. This is right.
Okay, doctor, but I have a question regarding this. We can't do it manually, can't we?
We can or we can't, you said?
We can't control. Can we?
Manually, we already made something like that in our lab. However, طبعا this system is automated system. It's called automatic voltage regulator. So it's based on closed loop control and based on measuring the required power or current and start control the excitation automatically in order to reach to the same value of voltage. This operation شباب takes few cycles. Few cycles, it means several tens of milliseconds. Okay?
Okay, clear.
This is شباب regarding the voltage. For that, we can say grid is constant volt. But what about the frequency? Let's now discuss the issue of frequency. طبعا frequency شباب it's related to speed. Now, let me give you a practical example. If you are carrying a load of 10 kilograms, for instance, and I asked you to run at certain speed. Can you run at the same speed if we increase the load 5 times, for instance?
No, we can't.
With the same effort? طبعا it's impossible. If you are paying the same effort and we increase the load, so the speed has to be decreased. This is logic. And it's logic also for electrical machines. So here we have a curve, which is the relation between frequency and the power for any synchronous machine. As you can see, if the power demand increase, the frequency will decrease. And frequency is nothing but speed of the machine as well. Frequency is the electrical speed and the rotation or RPM is the mechanical speed, and both are related to each other. So this means by increasing the power, the frequency will be decreased. What's happened in synchronous machines, in power plants, in order to keep this frequency constant? Because as we agreed, the grid frequency is constant. All of time, we deal with the grid frequency. How we can do that? Here we have a relation which describes to us how we can do this increase in speed to return again to the same operating point. Assume that we have a case number 1 where the generator is delivering BG1 at the grid frequency. If a delta P is demanded from this generator, this means that at BG2, which is the new value of needed power, the frequency will be reduced to this value, this is case number 1, or this is the governor curve. We can say this is called governor curve. Case 1 here means governor curve number 1. In order to achieve the same frequency, we have to change the governor curve. Changing the governor curve can be controlled by a system called speed governor. So the speed governor, if we have, for instance, a steam turbine, the steam governor will increase the valves, will open the valves to increase the steam in order to return to the same operating speed again. This increase in steam will lead to increase in speed and torque to reach to the new point here يا شباب. طبعا speed governor depends on mechanical system, so it's slower than the automatic voltage regulator system. So AVR system is faster than speed governor system يا شباب. Why? Because speed governor depends on mechanical valves, and mechanical valves takes time to be controlled compared to electrical switches. طبعا يا شباب يعني we have 3 systems are related to each other in our work in electrical engineering: thermal, mechanical, and electrical. All of time, electrical time constant is very small compared to mechanical, and both are very small compared to thermal. Yani if we have an example, if you have electrical switch connected with one, what if you turn on the switch? Is it going time in order to turn it, or instantly you will find that the lamp is turned on?
Instantly.
طبعا يعني nothing is made instantly يا شباب صح؟ يعني it takes few milliseconds maybe. However, your eye cannot recognize this very short time. So we can say electrical time constant is very small. Electrical time constant is very small, or electrical system is very fast. Type. Regarding mechanical, if you have electrical motor and you turn the supply off, what will happen to the motor? Is it going to be stopped immediately, or it will take some time up till discharging the energy? Huh?
It will take some noticeable time.
It will take some time, and so the mechanical time constant. So the mechanical time constant is greater than electrical time constant. Like, what about thermal? If you have some boiled water on oven, for instance, and you turn the oven fuel off, can you put your hand in the water just after turning off the oven? It's impossible, because it will take very long time to cool the water. And this is this is a simple example to compare between electrical, mechanical, and thermal time constants. For that, we can say that the speed of automatic voltage regulator is higher than the speed governor system. Speed governor system يا شباب, it's called sometimes as load frequency control system, LFC, or load frequency control. So we have here a block diagram which describes the operation for both of systems, شباب. How it could be made in power plants. We have here, this is our synchronous generator. This is the field winding of the synchronous generator. And here we have the excitation system, which is used to supply the field winding. By measuring the voltage, by using any voltage sensors, شباب, we can recognize if there is any drop in the voltage here. And based on that, the excitation, the AVR system will control the excitation voltage in order to keep the voltage constant. So this part here is responsible for the AVR system. We sense the voltage magnitude, and based on that, we start controlling the excitation. So this is the AVR. For the speed governor, we measure also the signals of volt, which can be used to get the frequency value by using frequency sensors. And then, based on the frequency value, frequency can be changed to be increased or decreased according to the power change. Based on that, يا شباب, the load frequency controller or the speed governor will sense the change in this power and accordingly will increase the or control the valves, the mechanical valves, to change the power of turbine in order to keep the generator working at certain speed. تمام يا شباب؟ So this is يعني a very simple block diagram for both of systems يا شباب, for AVR and for LFC or speed governor. Any question يا شباب regarding the operation to control the frequency of اتفضل.
I have a question. I wanted to make a little bit link. This is load frequency control.
Yes.
Is it the same as the frequency control as we know in the power system? I mean primary control and secondary control, or it's different?
Primary control and secondary control, it's like classification of control stages. Okay? Primary control, secondary control, or we can say as master control and slave control, whatever. This is just classification for control stages. The frequency control of power system, it's the same like what we are discussing now. This is exactly what we make for frequency control. It's not only for generator. By the same way, it can be made for any system. For instance, let me assume with you that we have a PV system. Okay, we have a grid. And this grid is connected to a PV system by means of power electronic converters. طبعا in order شباب to connect PV, which is a DC source, تمام, or considered as DC current, we have to use power electronic converters شباب. يعني two types of power electronic converters are used. One is called the boost converter or DC to DC switched mode regulator, and another one is called the inverter. يعني finally we will have some power electronic converters. These power electronic converters converts from DC to AC at the same voltage and frequency here. Right. Here we do not have any inertia like what we have in electrical generator. What will happen if we have increase in power here? The frequency here will be affected as well. We can control the frequency of grid by controlling this power electronic converter. It's called the frequency control or line frequency control. How we can do that? And there are many techniques used to make this control, like something called virtual inertia. Yani we make a virtual inertia to this system. Even we do not have any inertia because it's just the electrical system now. But we create something called virtual inertia. This can be achieved by controlling the frequency. So whatever the control system, it can be for a PV system, it can be for any renewable energy source, even if it is not having any mechanical system. تمام يا شباب? Even if it is not having any inertia like what we have in synchronous machine. Okay, so this is called the frequency control of power system. تمام يا باشمهندس؟
Yeah, clear. Thank you.
Good. Okay. طيب. So now يا شباب, we agreed together we have two main systems that are used in power plants in order to control the synchronous generator operation, which are AVR system and speed governor. يعني I wish that both of systems now يعني are clear for you. طيب.
Doctor,
تفضل.
I still like have some problems or some concerns with the second system,
تفضل.
the speed one. So does it only like control it by controlling the frequency, or like
let me repeat or يعني ايه summarize again the detail of operation. يعني the target is to control the frequency. The target of the speed governor is to control the frequency or keep the frequency constant. How we can keep it constant? By controlling the amount of steam which is going to enter to the turbine here. You get it?
Okay, okay.
So we control the speed. If we control the speed, we can control the frequency. So firstly, we measure the frequency. And if we have any reduction in frequency, the turbine will be over speeds in order to reach to the new frequency needed. If we have increase in frequency due to any decrease in load, the speed of the turbine will be reduced by means of the load frequency control or speed governor. So speed governor system just controlling the controlling the speed of the shaft of turbine generator by means of mechanical valves, تمام, in order to keep the frequency constant.
Doctor, but do you have limits there? Like there are limits for it?
طبعا there are limits. طيب, we discussed before, شباب, we have something called steady state and transients. If we go back to the stability definitions before, we said that we have steady state stability and transient stability. All what we are discussing now, شباب, are related to steady state stability. This is for gradual increase in loading. However, if we have any transient, we have to have different systems, شباب. These systems are not sufficient to make all of these changes at very short time. If we have very high increase in load, suddenly increase in load, this is going to decrease the frequency. ماشي? And decreasing this frequency may be due to a short circuit. Short circuit will have the same effect of high load, because if you can imagine, if we have here in this slide, if we have a generator like that, assume we have on this bus bar, we have here synchronous generator, and this synchronous generator is connected here. What will happen if you have short circuit here? What's the meaning of short circuit, شباب? Or what is the effect of short circuit? Short circuit means
the load will be very high.
Huge current.
It will collect all of the surrounding power. You have current which should go to the grid here, or loads here and there and so on. However, this short circuit will collect all of these powers together. And due to the impedance of the short circuit, which is very, very small, almost zero impedance, the current will be theoretically infinity or very high. صح ولا يا شباب?
Yes.
Which means the effect on the synchronous generator will act like very high load, which means the power consumed from the synchronous generator will be very, very high. This will lead to very or sharp decrease in frequency. In this case, speed governor cannot work properly because speed governor needs time. So what is the solution now? We have to protect our system by disconnecting this fault. طبعا disconnection can be from here. طبعا all of these شباب are connected through circuit breakers. All of systems are connected through circuit breakers. Okay. However, which circuit breaker will be turned off? This is another issue. It's regarding the coordination between circuit breaker operation. This is inshallah, you will, if you take the course of power system protection, you will know exactly how we can design the circuit breakers in order to disconnect according to the nearest switch to the fault. تمام يا شباب? So this fault should be cleared from this switch here, because this is the most circuit breaker close to the fault. So this should be cleared or turned off in order to clear this fault here. تمام? and this is going to connect the high power which is taken from this generator. تمام? So the limits, yes, we have limits. We have limits for speed governor by means of delta B over delta F. So this value has to be according to certain numerical values. I don't remember the values now. However, I will share with you something يا شباب related to the control of the synchronous machine speed governor. It's made by many companies like ABB, like Schneider. I don't remember if the name is right like that or not. And Schneider is a French company. Okay, lots of companies شباب, but this is the main two companies that producing electrical equipment for power plants. تمام. طبعا like Alstom, like that I believe. تمام. Many companies are producing these devices for power plants. I will share with you, I believe, something related to ABB company. Okay, they have their own system which is used to make the speed governor. طبعا شباب, like any system, like any device, there are many versions. Okay, the most recent version, I will share with you the data of the most recent version of speed governors made by ABB. You will find it inshallah today on Blackboard. طبعا you can go through it, you can read whatever you need, and if you have any question we can discuss it later inshallah.
Sorry, Doctor. This is for the synchronized generator. What about the synchronized motor? Can we control its speed?
Synchronous, you mean synchronous generator or synchronous motor? طبعا for synchronous generator, now we are discussing the stability or steady-state stability operation of synchronous generator. Synchronous motor is simply a motor. You can control the motor speed by controlling frequency, and we will discuss it inshallah. Okay, so synchronous motor, like any kind of motor, like induction motor for instance, if you control the frequency of the supply, you can easily control the speed of the motor, and we are going to discuss it inshallah and during this topic.
By means of power electronics.
Yes. Controlling frequency now is made by power electronic only.
It's clear. Thank you, Doctor.
Is there anybody يا شباب took the course of power electronics?
Yes.
Sorry, good. So if you are speaking about the speed control of AC machines, there is something called variable speed drive. Variable speed drive. Variable speed drive is nothing but controlling voltage and frequency of AC motors. Okay, there are lots of techniques to control the different types of machines. Okay, one of the most techniques preferred in industry now is made by ABB company called direct torque control. Direct torque control, DTC. Okay, also it's based on variable frequency, variable voltage control. It's changing the voltage and frequency of the AC drive system in order to control the speed of AC machines. But to be honest with you, for now, the most motor used in industry up till we can say up till now, you will find induction motor is the main one used in industry. However, in the recent 10 years, the synchronous motors, especially the permanent magnet one, has been developed a lot, and it has better characteristics compared to induction motor. So it's used now a lot in the recent or advanced applications, like in electric vehicles. Most of electric vehicles now are based on permanent magnet synchronous motors. Okay, so we return back again to synchronous machines. However, the based field synchronous machine is rarely found now in our industry. يعني you cannot find it as a new product. However, you can find it in old factories. We still use the old synchronous motors, which are based on excitation, like the same construction here of the synchronous generator. طيب. Any question, شباب, regarding the today class? يعني I know that today class is يعني the basics are very important to the operation of power plants, and you will find it a lot, inshallah, in your life when you join يعني any power plant or any يعني huge systems. Okay, يعني so يعني we did not cover any examples today. Inshallah, next class we will discuss more about synchronous machines and solve يعني other solve some examples. Any questions, شباب?
Doctor, can I meet you after class?
Yes, okay. Okay, شباب, يعني see you إن شاء الله by the next week. السلام عليكم ورحمة الله.
يعطيك العافية دكتور.
Thank you, Doctor.
Thank you.
Welcome.